So बस let's start. एक second setup हो जाए. So this one. We're going to start with winter 1643. Okay, we're going to try and do this one. I'm going to start with the last question. Okay, that I'm going to do that first. Starting with question number 7. Okay, that's on page 18. Winter 1643. The question is about, I think it's about rate of reaction. So what happens in this question is you've got so you've got sodium. So you've got one second. So you've got sodium chlorate is the active ingredient, and it's in bleach, and the concentration of ions was determined by titration. So 10 cm of bleach solution was diluted to 250 cm in a volumetric flask using distilled water. So I think it looks like a moles question. So I'm just going to draw this. There's NaClO that's present in bleach. That is what he said. And 10 cm of this was taken, and you added water to it, and this bleach was turned into 250 cm cube. So this bleach was turned into a 250 cm cube solution. That is what the first line of the whole question states. And after that, you've got dilute sulfuric acid in excess of potassium iodide solution were added to this to a 25 cm cube portion. So they took a 25 cm cube portion of this, which remember contains bleach. I mean, this was NaClO. I mean, all of these had NaClO in them. This was also NaClO, and this one over here is also NaClO. And dilute sulfuric acid was added to it, so he's adding H2SO4 or H+1 ions to it. And potassium iodide is also being added to the same 25 cm cube solution to liberate iodine. So iodine was produced. So this is what happened over here. Iodine got produced in the same solution. And iodine got produced, and the resulting solution required thiosulfate to react with the iodine. So he finally ended up doing titration, and the iodine required how much? The iodine required 20.8 cm cube or 0.1 mole per dm cube. So 20.8 cm cube of 0.1 mole per dm cube of thiosulfate, which is, I think, S2O32- because they wrote the formula over here. So thiosulfate was required. So calculate the concentration of ClO ions in bleach. So you've got to find the concentration of ClO -1 in the original bleach over here at the top. So the first thing we're going to do is we're going to find the thiosulfate moles. How many moles of thiosulfate do you have over here? So Kiara, what do you get? And express your answers very carefully, right statements.
2.08 into 10 to the power -3.
So this is 2.08 into 10 to the power -3, right? So that means, so it's this reaction over here, okay? The thiosulfate reacting with the iodine. Oh, I mean, at the bottom over here, it's this reaction. And it's 2:1. So you can find the moles of iodine. If you want to find the moles of iodine, that's going to be the same moles divided by 2. What do you get for that?
1.04 into 10 to the power.
No, it's 4.13 here. Divided by 2. Actually, divided by. Okay.
You got 2:1, right? So it's going to be divided by 2. Okay. So you found that. Where did all that iodine come from? I mean, where did you get this iodine? This iodine came when the H2SO4 and Ki reacted, right? The first one. ClO -1 Ki and H2SO4, they reacted. That is what formed the iodine. So you've got the moles of iodine, which is 1.04 into 10 to the power -3. So the moles of ClO ions would be exactly the same, right? So you'll find the moles of ClO ions, but in 25 cm cube in this solution over here. they're going to be exactly the same. So that's going to be 1.04 into 10 to the minus 3 as well. So you found the moles of iodine, and all that iodine got produced when you had this reaction, which was given over here. So the moles of ClO minus 1 would be exactly the same. And so in 25 cm cube, you have these many moles. So how many moles would you have in 250 cm cube of the original solution? So find the moles of ClO minus 1 in 250 cm cube. So that's going to be multiplied by 10, right? So it's going to be 1.04 into 10 to the minus 2 moles, right? Is this clear?
Yes.
And then finally, you have to find the concentration in bleach. So in the 250 cm cube, where did you get all these moles? All these moles came into the solution when you added 10 cm cube of bleach. So your 10 cm cube of bleach, all these moles came from that bleach over there, 1.04 into 10 to the minus 2 moles. Like all the moles in the 250 cm cube solution that you made, they came from the 10 cm cube bleach that you added into water, right? So all these moles are coming from the 10 cm cube bleach. So you have to find the concentration now. So what is concentration? It's moles over volume. So that's going to be 1.04 times 10 to the minus 2. And that whole thing would be divided by 10 cm cube, which is, I think, 0.01 dm cube. So what do we get?
1.04. 1.04.
Because we're getting 1.04 mole per decimeter cube. And then he says that an indicator was used in the thiosulfate iodine titration. So name a suitable indicator for this. So how do you detect iodine?
Iodoform reaction? No.
Iodine,
Like sludge.
there's a test for detecting iodine, and that's
Sludge, yeah.
that's how you detect iodine. And what will happen is if you have iodine, it's going to be blue in color. It's going to be blue or black in color, and it will turn colorless because the iodine gets used up in the reaction at the end. When you're titrating this, you have iodine, and that iodine reacts with thiosulfate, and it becomes colorless eventually when the iodine is gone. So blue 2 or blue black,
Yes.
blue colorless. Okay, so remember, titration is happening over here. So iodine is reacting. You have iodine in, so the color change would be that initially you do have iodine, so it's going to be blue black in color, and then after titration, the iodine will react. It will get used up, so it's going to become colorless. So remember this starch. This is something that you should remember, that starch is used to detect iodine. Okay. I mean, you would have known this, except a lot of you haven't actually done practicals. Okay. There are idiometric titrations, which where the indicator is actually starch. State when in the procedure you would add the indicator. So this is
At the
about
start?
At the end.
At the end. It's not going to be at the start. The reason is iodine is clearly visible at the start, because I mean iodine is blue-black in color, or if it's a solution, it's a brown solution, right? Like this is what an aqueous solution of iodine looks like. 1 second. So if you have aqueous iodine, and let me, if there is, I mean, this is how it's going to look like. So I'll just give you an idea that you can clearly see the presence of iodine. Like if there is iodine, you can clearly see the presence. The problem comes when the iodine gets used up. The solution starts becoming colorless. So for example, there might be iodine over here, but the concentration would be so less that you can't really see it with your eyes. That's when you're going to add the indicator. Is that point clear?
Yes, sir.
Yes.
So remember this as well, that you're adding thiosulfate from the top, iodine is slowly reacting. You don't need the indicator. But when it almost gets used up, that's when you need an indicator to know the presence of the iodine. So if there is iodine present, it's going to be blue-black. Starch indicator will turn blue-black, and if it's not, it's going to turn colorless. So towards, so you just have to state, no explanation needed. So towards the end, that's it. And next one is, okay, we've got this reaction. The concentration of chlorate ions can also be determined by, so again, it's bleach. Bleach has the chlorate ions, 0 -1. So you're saying it can also be determined by adding an excess of hydrogen peroxide to the sample of bleach and measuring the volume of oxygen gas produced. So H2O2 reacts with bleach, produces oxygen gas. So you can find the concentration by what? You can find the moles of O2, and you would be able to find the moles of NaClO in the solution. And you already have the volume as well. Now, when an excess of aqueous H2O2 peroxide was added to 5 cm3 of a different bleach, 82 cm3 of oxygen. So this is a question at room temperature. So you're going to do the same thing. You're going to try and find the concentration. And the starting point would be that you're going to find the moles of oxygen. So how do you find the moles of oxygen at room temperature and pressure? That is
so 82/24.
24,000, right?
Yeah.
How many moles?
Let me see. 3.42 times 10 to the power -3.
And the moles, so that's the first thing. Then the moles of bleach would be exactly the same. So you can find the concentration of bleach by dividing the moles, 3.42 times 10 power -3, and it's a what's the volume of the solution? That's 5 cm3, right?
5, yeah.
So 5 into 10 power -3 dm3.
Yeah.
So what's the final answer? Correct up till 2 significant figures, because your answer is your numbers you're using, they have an accuracy of 2 significant figures. So what are we getting? Now he's saying magnesium reacts with cold water. Okay, did anyone do this?
Mm.
0.684.
I said this one is 0.68. 0.68, okay, your mole per dm cube, no 4, okay, your answer cannot exceed, it cannot be more accurate than this one. So this is going to be 0.68. I said next one. What's the next one? You've got, this is about Kc, so write the expression for Kc product over reactant, so that's C3, H3, N3, O3. And the concentration of this thing into HClO concentration, that's going to be cubed and divided by C3, Cl3, and you have the N3O3 and water, and that's going to be
To the power of 3.
to the power 3. Now, since they haven't told us that this is an aqueous solution, they've actually they're writing HClO as a liquid. It's they haven't told us it's an aqueous solution. If they had told us that it's an aqueous solution, the water would not have been written in the expression. But I think it's not an aqueous solution. They didn't mention it's an aqueous solution. So in outer swimming pools, H2O is
Can water की concentration don't we consider मतलब at 1 or excess में होता है तो we don't really.
It's in large excess, we consider it as 1.
हाँ तो why do we write it over here? मतलब हमने ये क्यों लिखा है reaction?
No, because we don't know whether water is in excess or not. They didn't tell us. It's just, I mean, no information over here is suggesting that water is in excess over here. Do you get the point? And
Sorry.
maybe they're just adding a few drops of water to this liquid over here.
Yeah.
So, so there's no, if they had told us that it's aqueous, then water concentration would be in excess and it would be taken. So in outdoor swimming pools, HClO is decomposed by sunlight. The decomposition of HClO is a redox reaction, which forms a gas that relights. What is that gas that relights a glowing splint?
Oxygen.
So this guy explain the effect of the decomposition of HClO on the equilibrium in D. What is D? And state the effect on Kc. First thing, if HClO, what he's saying is that you put it in a swimming pool, the HClO decomposes in light and produces some gas. So the HCl breaks down. So its concentration would decrease, right? Because the sunlight is going to decompose it. Is that point clear? So where would the equilibrium shift?
Forward.
Yes, it's going to shift
To the right.
to the right to the forward side, right? It will favor the products. The equilibrium moves to the right. So what effect would that have on the value of Kc?
Increases.
No effect.
No effect.
No effect.
Remember, Kc only changes with temperature. Otherwise, no matter where the equilibrium shifts, the equilibrium always shifts to sort of counteract things so that the ratio of products and reactants, it remains a constant. So Kc will have no effect. If the concentration decreases, it automatically moves to the right. So to increase the concentration, to maintain that ratio, right? So the point is that Kc never gets affected. It only gets affected by temperature. It's saying suggest an equation for this. We know that he has stated that HClO decomposes and it produces oxygen gas, right? So what is the possible other product?
HClO minus.
HCl.
I'm assuming it's decomposing, it's breaking down, right? So it might produce hydrogen gas. It didn't give us any information about the other products, so we just made that up. So maybe it decomposes into H2 and Cl2 gases, and for that, there's going to be HClO. That was the only information that was provided. This is what I just made up. So maybe in the market scene, there might be other options as well, but that is one. And remember, he was just asking to suggest, when they use the word suggest, that just means you can make up things as long as they make some sense. Now, the buffer solution in blood is a mixture of carbonic acid and hydrogen. This is a buffer solution. Explain how this buffer acts to control the pH of the blood. So if I add more H+1 ions, where would the equilibrium shift?
To the right hand side.
Forward.
So you've got a weak acid, and you've got its conjugate base as well, right? So which one in this equation is H+1? Like, what is H+1 equal to? Like
H3O plus.
To the weak acid.
Yeah. Remember that H+1 and H3O+1 are kind of the same thing, right?
Yeah.
So when you increase H+1, the equilibrium will shift backwards, right?
Yes.
It's going to start moving backwards. What will happen is that the conjugate base HCO3-1 will start accepting H+1 ions, and it will start forming H2CO3.
H2 carbonate, yeah.
The equilibrium shifts left, and that is what happens when acid is added. Vice versa, when a base is added, where will the equilibrium shift? It's going to react with the weak acid. The weak acid, H2CO3, will neutralize the OH ions. It's going to release H+1. Water would be formed, right? And H3-1 is going to be formed. That's what's going to happen when a base is added, right? Is that clear? So just remember, you have to intentionally make this equation. You can't just say that the equilibrium shifts right and left, which is happening. but you have to make this equations up. There's a conjugate base and there's a weak acid. So when you add an acid, the conjugate base reacts with it. When you add a base, the acid reacts with it, right? It releases an H+1. When you add the acid, the conjugate base accepts H+1. And the patient's blood has this ratio and calculate the pH of the blood. So we're going to go to our expression. What's the weak acid expression? That you have H2CO3, right? It's going to ionize. It's going to produce what? 2 ions, H+1 and HCO3 minus 1, right? So what is your K expression? The K expression would be H+1 concentration into HCO3 minus 1 concentration divided by H2CO3 concentration, right? So that's your standard expression for K. Now they've already told you the HCO3 minus 1. So they've told you this thing. They've already told you this ratio. That is already given. And that's 9.5 ratio 1, I think. The K value is given as well. That's 7.94. So what is H+1? According to this, the H+1 concentration would come out to be, it would be K, 7.94 into 10 to the minus 7 into 10 raised to the power minus 7. And that's going to be multiplied by what? 1 over 9.5. Correct me if I'm wrong. What is this ratio? This is 9.5 ratio 1, right? On the other side, it's going to be 1 over 9.5. So what do we get for this? And then you take the negative log. So tell me what the pH is.
So आपने उल्टा नहीं लिखा? Isn't it 9.5 over 1? वो तो
over here it's 9.5 over 1, right?
This shouldn't it divide? K को divide नहीं होना चाहिए.
9.5.
Yeah, I want to find H+1 now.
अच्छा, yeah, ठीक है, तो you just convert it. ठीक है.
The K is over here. I'm going to take this to the other side, right?
8.36 times 10 to the power minus 8.
So just a second. What are you getting? It's 8.36.
Yeah, that's what I find. 8.36 times 10 to the power minus 8.
Minus 8.
Yeah, to the power minus 8.
And you're going to take the negative log because you have to find the pH. So what is
minus log?
What's the negative log of this thing?
7.1. Just 7.1.
Okay, so the final answer would be 7.1. Okay, is this clear? I mean, it's just the same expression. They just stated it differently. That's it. And that was the last question. So we're going to move to the previous question, which is organic. You're given 2 molecules and name the other functional groups present in each molecule. So they both contain benzene. What's the other functional group? What is this one? That's
A carboxylic.
Okay, so ibuprofen is going to have
amine or amide.
What is this one? It's 2 groups, right?
Amide.
Amide.
Okay, that's an amide.
You can also have a phenol. Yeah?
Also phenol as well. OH with benzene, that's phenol. State what is meant by the term amine chiral. That's easy. That's 4 different. When you have a carbon that's bonded to
4 different atoms.
Or groups, okay? So that is what chiral is. Draw the stereoisomers of ibuprofen. So which of these carbon atoms is chiral? Is a double bond? Is this?
The next
This
two,
one.
yeah.
Okay, this one is the one that's chiral, right? You can benzene is never chiral. Always think of benzene as 6 carbons making alternate double bonds. That's an easier way to actually think about benzene. Like there is alternating double bonds. Always think of it that way. In that way, it's never going to form actually no optical isomers would be possible. So I have to draw this one. It's got a CH3 on one side. It's got a carboxylic acid on one side. It's got so this one has a CH3 on one side. It's got an H on one side. What else did we have? It had a carboxylic acid group on one side, right?
Mm-hmm.
And the benzene.
I says, what is this thing? Like on one side, it's got this entire group. So
C6H4 and C2. Yeah.
one. So this is C6H4. That's benzene. Remember benzene. How to count the hydrogen? There will be 4 hydrogens over here, and over here the bonds are already complete. So you got CH2. So you got a CH2. Then you have a CH with 2 CH3 groups, right? So I'm going to write this. That is what is present on one side of this carbon atom. So that's C6H4 one second. I got C6H4. And I got a CH2, and I got another CH, and I got 2 CH3 branches. So I should have drawn it on the other side, but I would have to draw the other version now. So what's the other version? Draw a mirrored version. You can't really fit it in this because this should have been drawn on the other side. That would have been easier. But this looks good. ठीक है.
Sir, stereoisomers में does it matter कि हम हर bond different बनाएं या ये bond arrangement differ करे? Let's suppose मतलब जो ये bond arrangement है.
I mean the CH is on top and the H is over here. That is the same thing. No difference.
नहीं और plus these bonds. I mean ये हमारे पास 2 bonds are in the same plane and 2 are in different plane. तो does it matter कि हम ऐसे ही बनाए कि नहीं चारों को different plane में बना सकते हैं?
The 2 would always, like the conventional way is when you draw a tetrahedral structure, 2 are always in the same plane.
Yeah, okay.
In any shape, 2 bonds are always in the same plane, no matter what the angle is.
और सिर्फ plus वो square planars में हमारे पास वो जो we have to make cis trans तो उसमें we either make 2 bonds that are in the same plane and 2 other bonds that are in the same plane, right? So either हम तो left right को कर सकते और या cis trans opposite कर सकते हैं.
Square planar के अंदर you've got it's always in the same plane. I mean you only have to remember this example, which is cisplatin. So either the CLs are together or the CLs are on opposite end. That's it. Okay. But that is a geometric isomer. That's not an optical isomer.
Yeah. Okay.
As I draw the structure of the organic product when ibuprofen and paracetamol reacts actually with LiAlH4. So reduction LiAlH4. What would LiAlH4 react with?
The amide group to form amide.
It also reacts with
acid to form alcohol. Yeah.
I mean, this is the carboxylic acid part is AS. LiLH4 reduces it to an aldehyde, which gets further reduced to an alcohol, primary alcohol. So the carboxylic acid, I mean, I'll just draw it over here. That the carboxylic acid over here, the carbon will turn into, it will turn into a primary alcohol. The amide, the double bond O will go away, instead replaced by H's. So reduction is going to happen. The second one is the organic chart.
So ये paracetamol में हमारे पास amide linkage था और it converted to amine.
It's going to get converted to an amide. Okay. You have an amide. You add LiLH4, the double bond O goes away. It gets replaced by hydrogens. So it turns into an amine. So that's this reaction over here. Anyways, ibuprofen contains a chiral center and shows stereo. What is meant by the term? That's the same question. So we got a problem with paracetamol. We just drew it over there. A student carried out some reactions with solutions of ibuprofen and paracetamol using reagents D and E, and the following results were obtained. So D reacted with, so you have to figure out what these reagents are. So what is happening is D reacts with one of them, but not the other one. E reacts with the other one. So what is one reagent that will react with this and not this one? Like,
there's an acid test, maybe sodium.
okay. Okay, so you got a carboxylic acid, right?
सोडियम तो फिनोल के साथ रिएक्ट नहीं कर सकता.
But you're going to use sodium carbonate.
Any carbonate will do.
Okay. You're going to use sodium carbonate because remember, for acids, alcohols, I mean, you've got three things, right? You've got, remember the relative acidities of alcohols, phenols. I mean, phenols are C6H5OH. And then you've got carboxylic acids, right? So sodium reacts with all three of them. When it comes to alkalis, the alcohols are not going to react. NaOH will react with phenols. It will also react with carboxylic acids. And when it comes to weak bases, carbonates, then only the carboxylic acid will react, not the other ones. So alcohols are the weakest. They only react with sodium. Phenols are slightly more acidic. They react with strong bases like NaOH and sodium metal as well, but not with weak bases. Carboxylic acids, they react with everything, every base, whether it's a weak or a strong. So you're going to use carbonates. That's the main differentiating factor that, so you're going to use carbonates. What about the other one? One reagent that reacts with this and not that one.
Yeah, we have a phenol there. So phenol usually reacts with bromine, bromine.
So the test for phenol, the identification of phenol is you add Br2 aqueous, a white precipitate is going to be formed. It's a highly activated benzene, and you will get bromine on all.
Sir, apart from phenol, bromination, किस benzene ring की और होती है?
Phenylamine. This one, okay.
Phenylamine or
remember, okay, phenylamine, you add Br2 aqueous, no catalyst needed, and it will form a white precipitate. And the other one is phenol. You add Br2 aqueous, again you get a white precipitate. All three positions you get. So their reactions, phenol and phenylamine, the reactions are kind of similar. But when it comes to arenes, you need a catalyst. You need FeCl3 or AlCl3. With the bromination of benzene, you also need a catalyst. So in that case, you need a catalyst. But for phenol and phenylamine, it happens at RTP.
Sorry.
So next one is give the structure of the organic product when, so they're asking for the product as well. So we're just going to do the working over here. So if I add bromine, where will the bromine get added? It's going to get added to positions 2 and 6. The fourth position is already full. And if I add sodium carbonate to this, what will happen? The carboxylic acid, it will,
on OH,
right? And water and carbon dioxide would be produced. So those are going to be my product, and that's no, the question still continues. You've got this reaction, and they're asking you to write an equation for this. So it's an acylation reaction, which is acyl chlorides. So acylation is over here that when you react an acyl chloride with benzene, the carbon, which is the Cl bond OCl carbon, which is strongly positive, is going to go and get attached to the benzene electrons over here. So for that, you need AlCl3 plus C. That's the reaction that's happening. So you have to write an equation. So what is the formula of this thing?
C6H5, CH2, and CH3CH3.
Starting with C6H5. This carbon will have 2 HSCH2 and then CH and 2 CH3s. Two of them, right? And plus CH3, COCl. And the product is going to be, I mean, it's going to be CH. The CH3 twice. I mean, starting from here. Then there is CH2. Then there is C6H4, that's your benzene, followed by CO. and right at the end, that's a C with CHs, so that's CH3. So that's going to be your product, and that's your equation. So complete the mechanism for it.
Is
सर
that
पहले
a-
वाले रिएक्टर के अंदर बेंजीन किधर है?
It's not asking for the reformation of just the catalyst there, is CH3COCl and
One second. First question, you've got, this is benzene, right? C6H5.
Yes sir.
There's CH2, there's CH, C with CHS, C with CHS, right?
सही है ठीक है sorry never mind sir I understand.
I said next one. So he's talking about the mechanism. So what's the mechanism? So the mechanism that what electrophile is produced initially.
There's CH3CO
Okay, so remember this.
negative.
That, so what happens is that CH3, C double bond O, Cl. When you have an AlCl3 catalyst, what the Al does is that it pulls that Cl. The carbon is strongly positive. So what happens is the Cl breaks off, and so that is what the catalyst does. It polarizes the molecule further, and it turns into AlCl4 -1. And the carbon, which was already very strongly positive, is now a fully positive, right? So this thing will get attracted to the electrons over here. So your CH3, C double bond O positive is going to get attracted to this. Let me draw the arrow correctly. So it's going to get attracted to this benzene. What's the next step? The next step would be that that an intermediate would be formed, that the benzene ring. So C double bond O and CH3 will get attached to it. There's an H already there. The benzene electron cloud will become partial, and you've got the branches over here. That's I think this is. So what's the next step? Because the carbon took electrons from the benzene, so the benzene ring became an ion. The H is going to return the electron. So that's your last step, that the H decides to give back the electron. So this is exactly the same mechanism as nitration or bromination. And the mechanism is called electrophilic substitution. You can remember all benzene reactions that kind of have the same exact mechanism. So next is
सर थोड़े से ट्रांजिशन मेटल्स से क्वेश्चंस कर सकते हैं वो फ्रीक्वेंसी वाले थोड़े से सर जो वेवलेंथ वाले होते हैं एंड जो शेल्स वाले होते हैं DXY DXZ2 वो सब
नहीं NMR करना है कि नहीं करना
NMR सर आपने करा दिया था ना अगर आप चाहते हैं तो एक दो क्वेश्चंस करा दें उसके
Let's move to transition metals. ठीक है this is the transition metal. First thing, what is meant by a transition element?
सर ये वाला तो ठीक था ना जो हमने किए थे जो बहुत सारे आयंस थे ये वाला ठीक था मुझे ज्यादा उसमें फ्रीक्वेंसी वेवलेंथ क्वेश्चंस में और वो DXY
ये NMR के क्वेश्चन थोड़े बहुत करा दे ये केमिकल शिफ्ट वाले स्पेशली वो कार्बन NMR
हाँ लेकिन नहीं मुझे नहीं समझ वो DXY अच्छा प्लेटिंग के why are they colored?
Yes sir.
मैं उसका go through कर देता हूँ क्योंकि it's always the same type of question. Transition metals, it's always the same exact type of question. ठीक है.
Okay sir, thank you.
It's I'll just give you a quick recap of this. Okay, you've got the first thing is they're going to ask you about what transition metal definition, that it's going to form stable ions. वो सारे high melting and boiling points because they've got more protons, so the charge density is higher. So which is why the metallic bonds are stronger. You can go with that. Catalysts, etc. But the more important one is, first thing is you should know how to draw the orbitals. DXY, DXZ, DYZ, DX square minus Y square and DZ square. 2 of them lie on the axis and 3 of them they lie I mean, the electrons, they exist between the axes. Now, for a ligand exchange, TK, you should know the colors of copper and also of cobalt. Okay, if you've
Yes,
got
sir.
those kind of, you should know that specifically copper and cobalt, nothing else. TK, copper and cobalt, that's the only thing that is in your course when it comes to ligand exchange and the colors of complexes. So what happens is, okay, copper with water, remember copper ions with water, that's blue. अगर उसमें if you add NH3 to it, it will, the water molecules will get replaced by NH3, so that's a deep blue solution. And it could be all of them can get replaced by NH3. If you add Cl is bigger in size, so if you add concentrated HCl, the copper ions will get surrounded by Cl, but there would be only 4 of them, and that's a greenish yellow solution. And if you add NO, so what happens is that the water molecules get replaced by OH ions, but it eventually ends up forming a precipitate of copper hydroxide, which is an insoluble precipitate, which is pale blue. So you should know all these complexes. Cobalt is exactly the same.
Cobalt वाला सर वो याद है.
The cobalt has some कुछ. You should know what the equations are. All of them, okay, copper, if it's with water, you add OH ions, it will form a blue precipitate of copper hydroxide. If you add NH3, a small amount, so initially the NH3 reacts as and ends up producing OH ions, so you get a pale blue precipitate of copper hydroxide. But if you add NH3 in excess, so the copper gets surrounded by NH3 and it forms a deep blue solution of FeO. So you should know the equations as well for these and repeat for cobalt, except that they're going to have different colors.
सर हमारे सिलेबस में वो है ना जो ट्रांजिशन मेटल्स के अंदर इलेक्ट्रॉन शेल का कहते हैं.
नहीं, इलेक्ट्रॉन शेल्स का क्या कहते हैं? इलेक्ट्रॉन शेल्स तो है मतलब these substances, right?
सर मैं एक सेकंड आपको एक क्वेश्चन ढूंढ के देता हूं पास से पहले अपनी
उसका तुम कह रहे हो, ठीक है. Next to चीज है, I mean, you should know what is a monodentate ligand, what's a bidentate ligand. They're going to ask you to draw bidentate ligands. Polydentate ligand, that is impossible to draw, but you should know you should have some knowledge of it. Okay? It's going to be a big molecule, lots of different parts having lone pairs, and the metal ion will be stuck in the middle, attracting those lone pairs.
So can I see the bidentate ligands, please?
You know?
All right. Yes, sir. Sorry.
The bidentate ligands, okay, they'll ask you to draw this. Okay? They'll just draw one. So the lone pair on N over here is getting attracted to it. The lone pair N over here is also getting attracted to it. So you'll it's the same.
और दोनों NH2 के दरमियान CH2 लगे हुए हैं. ठीक है सर.
But it was one molecule, right?
Okay.
So I said the other thing is they're going to ask you about certain shapes of complexes, specifically cisplatin. That's you have to remember that. Okay. I said, why are they colored? Okay, so you're going to get a question on why are they. Well, usually there's always a question on this. Why are they colored? When you have an octahedral complex, the ligands, they come in and they get attracted to the metal ion which is stuck in the middle. Okay. So it's just that the water molecules are getting attracted to it, and the ion is stuck in the middle. The ion has a D subshell. Okay, ion has a D subshell, and the D subshell, we just saw those D subshells initially. That you have electron densities between the axes, and you've got electron densities that are lying on the axis. Somewhere we.
So yes, sir. Would DXY, DXU, हाँ sir.
Okay. So remember this, these ones, the electron density lies between the axes. These are the ones where electron density lies exactly on the axis. Initially, all of them are identical, just like Px, Py, Pz. I mean, Px, Py, Pz, there's nothing different between them, right? Except for the direction. They're all exactly the same. So the D subshell is identical at the moment. All the orbitals are exactly the same. That's known as a degenerate orbit, degenerate subshell or degenerate orbitals. That they have the same energy levels. But when you form this complex, this one, when you form this complex, so because of the ligand repulsion, in certain d orbitals, it is harder to keep electrons. But for example, this water molecule has electrons, and those electrons would repel the electrons in this green orbital over here. So it would be harder to keep electrons on the axis, right? Is that fair?
Yes, sir.
And it would be easier to keep electrons between the axes. Okay, the ligand is further away from this. The ligands are approaching on the axis, so it's harder to keep electrons on the axis. Easier to keep electrons in the pink orbital over here, which is between the axes. So what happens is, initially your d subshell, they're all identical, but now what happened is that it has split into two energy levels. On the axis, it's harder to keep electrons. Between the axes, it's easier to keep electrons. Is that clear?
Yes, sir.
What you're going to write is that the d subshell splits into two energy levels. And now what can happen is that the electron can sort of jump around. The electron could move from a lower energy d orbital and jump to a higher energy d orbital. And to do that, it would have to absorb a certain frequency from the visible spectrum, which is why you see a complementary color. If it absorbs red, so that means you're not going to see red. So you're
Is
going to
this
see all,
reflecting?
you're going to see all the other colors except the red. Okay.
Okay, sir.
So if something appears to be blue, that means blue is the only thing that it's not absorbing. It's absorbing the other colors, but not blue. So this is a typical explanation that you're going to write, that due to repulsion from lone pairs on ligands in metals, these substances energy levels, and the electrons from the lower energy d orbitals, they gain energy and move to higher energy d orbitals. And there's an energy gap which matches frequencies which are part of the visible spectrum. Hence a complementary. Okay. Why does the color change when the ligand changes? So if you have a different ligand, the different ligand will exert a different amount of repulsion, which creates a different energy gap as the d subshell splits. So it is the same splitting, but the energy gap would be different.
तो frequency
And-
भी different होगी, hence visible spectrum से भी जो absorb नहीं करेगा वो उसका color आएगा.
Okay, so different complementary color would be seen. And
Same.
one thing you have to remember is that in octahedral complexes, the ligands approach on the axis. So it is harder to keep electrons on the axis because there are ligands present over there, right? Okay. So in an octahedral complex, it's harder to keep electrons on the axis. It's easier to keep electrons between the axes. Is that clear?
Okay.
But in the tetrahedral complexes, the ligands are not approaching on the axis. 109-degree angle of the tetrahedral meso. So they're not, the ligands are not on the axis. So which is why it's actually easier to keep electrons on the axis and more difficult to actually keep electrons between the axes.
Sir,
Understood? Haji.
can we do moles के कुछ questions? Because I'm getting stuck on moles के questions. जैसे you did अभी on the paper 2016 वाला, उसी तरह के और.
तो देखा पड़ेगा एक सेकंड ढूंढना पड़ेगा पेपर just a second.
I have a question वैसे.
ये बताओ.
May June 2020 variant 42.
Which question?
Question 2 part E.
Question 2. So yellow part.
Yes.
Did we do one question similar to this? I will do this quickly.
Yeah.
So the question is, there's an iodized salt. Okay. There's an iodized salt, sodium chloride mixed with a small amount of sodium iodide. So what's happening is you've got this. You've got this salt, and it's got two things. It's got NaCl as a plus it also has NaIO3, right? So 50 grams of this thing is dissolved. So this is 50 grams. It's dissolved in distilled water and the solution is made up to, so 50 grams is dissolved and it's made up to a 250 cm³ solution by mixing it with water in a volumetric flask, and 50 cm³ of this solution is pipetted. So he took 50 cm³ of this. So we've got 50 cm³ of what, NaCl plus NaCl, I need what, NaIO3, right? That's a 50 cm³ of this. And is added to potassium iodide. So you're adding potassium iodide to it. And he says a reaction happens and there's iodine produced, right? So this 50 cm³ solution, you got iodine produced. And the iodine produced reacted with sodium thiosulfate. So this is now reacting with thiosulfate, which I think is H2O3. So it's exactly the same question. So how many moles of thiosulfate do you have?
So it's just like a back titration question. Okay.
So how many moles is this?
2.48 into 10 to the power minus 5.
2.48 into 10 to the minus 5.
Yes.
So that's the moles of thiosulfate, right? So thiosulfate reacts with iodine in what ratio? 2:1. So the moles of iodine would be half of that, which is going to be 1.2 times 10 to the minus 5, right?
Yeah.
So you found the moles of iodine. Where did all the iodine got produced? The iodine got produced in the previous reaction, right? So all this iodine got produced in this reaction, which is 1.2 times 10 to the minus 5, right? Well, all this iodine in this reaction got produced over here. If you've got 1.2 times 10 to the minus 5, so how many moles of iodate ions would you have?
Divided by 3.
Divided by 3.
Divided by 3. So it's going to be 4 times 10 to the minus 4.
4.1 into 10 to the minus 6.
That's a 4.1
into 10 to the power minus 6.
That's a 10 to the minus 6. Actually, where did the 1 come from? Because this is 1.2. Yeah, the accurate neither.
1.24 है.
That's it. So anyways, it's 4.1 into 10 to the minus 6. So you found the moles of iodate over here. This is where iodate is, right?
In 50 centimeters. Yeah.
So how many moles would there be in 250? That's going to be 5 times
into
more,
10.
right?
Yeah.
So you're going to multiply it by.
What?
ये clear है कि ये हुआ है कि you found the moles of thiosulfate?
हाँ, 4.1 तक समझ आ गई थी.
तो ठीक है. So you got 4.1
minus 5 होगा. हाँ, ठीक है.
वो तो एक से मैं वो कर लें. As you found the moles over here, right? 4.1 into minus 6 or minus 5 है?
Minus 6.
Minus 6?
Yeah.
So यहाँ पे moles आ गए. You found the moles over here, right?
Yes, sir.
So those moles were, you're titrating 50 cm³, right? You just took 50 cm³. Your original solution is 250 cm³. You took that 50 cm³ out of that 250. So the original में कितना होगा? That's going to be 5 times more. Like in 50 you have this much, so in 250 you'll have 5 times more.
5 times more. Yes, sir.
So वो आगे, so what do you get for this?
2.51.
2 point? Into what? 10 is per?
मैं उसको मल्टीप्लाई करके I माइनस निकाल रहे हैं.
नहीं, IOC minus 1 निकाला.
minus 5 सर, minus 5 आ रहा है.
minus 5.
उसको मल्टीप्लाई बाय 5 क्यों कर रहे हैं?
क्योंकि 50 हमने जो moles निकाले हैं, the moles that we found out, that was in 50 cm³, right?
Yeah.
So 4.1 into 10 to the minus 5 we calculated. We found the moles of iodine, right? And then we divided that by 3 to find the moles of IO3 minus 1. So we found the moles of IO3 minus 1 in this 50 cm³ solution, right?
Yes.
वो ratio लगाओ ना कि 50 cm cube you have this much. So what will be the moles in the original 250 cm cube? That's going to be 5 times more, right?
Yes, sir.
Yes.
So इसके अगर moles ये हैं, it's 4.1 into 10 to the minus 5. So the moles in 250 are going to be 5 times more. So that's going to multiply by 5. That's going to give you this answer. Clear?
Yes, sir.
And where are all these IOC minus 1 coming from? They're coming from this thing, right? So they're coming from the 50 grams that you dissolved. So that means IO3 minus 1 had 2.51 into 10 to the minus 5 moles. Because all of these moles in the 250 cm cube solution are coming from this thing, because this is the thing that you're dissolving to give you these length moles.
No, sir. I got confused. 5 से multiply क्यों कर रहे हैं?
ये clear है कि उसने what he did was कि when he made the 250 cm cube solution, उससे आगे he just used 50 cm cube of it. But इसके आगे ना he's just titrating 50 cm cube of it. So ये clear कि you found the moles in 50 cm cube, right?
Yeah.
उससे आगे simple है कि let's say you found 10 moles in 50 cm cube, right? Your original solution is 250 cm cube. So how many moles would they be present in 250 cm cube? 5 times ज़्यादा होगा. Ratio क्या है? That's if you have these moles, मतलब उसको मैं draw करके कर देता हूँ कि this was a much bigger beaker. This is what your original solution was, right? A 250 cm cube. But in the next step, you did all the reaction and you just took a small beaker of it, which was 50 cm cube. So all your titration happened in that 50 cm cube solution. So you found the moles in this small, tiny 50 cm cube solution. So how many moles would you have in the original solution, which was 250 cm cube?
Into 5 कर दूंगा.
Okay. सही है.
ठीक है? And
सर हमने तो moles उसके सिर्फ IO3 के निकाले ना, लेकिन
हाँ तो NaIO3 would have the same moles, ना, क्योंकि it's 1:1, right? क्योंकि 1 NaIO3 will produce 1 IO3 ion, right?
yes sir.
तो अब मुझे पता नहीं है कि what was he asking for? He's asking for the mass of NaIO3. So you need NaIO3, right? So you
Okay.
just multiply it by the MR of this thing, whatever that is. तो क्या आ रहा है उसका?
So 48 plus 23.5 is
40. As I can clear, it becomes a lot clearer if you. I said now the difference between, I'll tell you the difference between A2 moles question and AS moles questions. In AS, the question was divided into a lot of parts. Okay, you had a lot of steps. Even if you didn't understand the question, if you just follow the steps, you would probably end up with the answer. Over here, the problem is they don't usually give you any steps. They just give you the whole question and you have to figure this out on your own. So it's a lot better if you just get something. Okay? You had started off with 50 grams, you made a 250 cm cube solution, then you took a 50 cm cube sample of that solution and you added Ki and a reaction happened, it ended up producing iodine, and then that iodine was titrated with thiosulfate. Okay? So we did the whole thing in reverse now. We found the moles of thiosulfate, and using ratios, we were able to find out the moles of iodine. And all of that iodine was coming from the reaction that was happening over here. So all that iodine came from this much IO3 minus 1. So we found the moles of IO3 minus 1, but we found the moles in this 50 cm cube solution. So in your original 250, the moles would be 5 times more. You have 50 ratio 250, so there would be 5 times more quantity. So the moles would be 5 times more. And all the IO3 ions are coming from this salt. So it's all coming from the 50 gram salt over here. So So these moles, 2.51 times 10 power minus 5, all of them are coming from NaIO3. And the last thing is you're going to multiply it by MR to find the mass. Okay, clear? Is there any other question? You clear?
Sir, इसका इसी पेपर का एक और क्वेश्चन है.
What's up?
Question 4 part 2 नहीं part D.
Question number 4 part.
D उसका जो structure बनाना है.
D या B?
D.
I said D is this one, right? Name the functional groups in addition to benzene present in phenolphthalein. Phenolphthalein reacts with two reagents shown in the table. Complete the table by an excess of hot NaOH. I'll just do an excess of Br2, right? So I'm just going to do this one. This is phenolphthalein. Excess of hot NaOH. So what does NaOH do? First thing, it will react with the phenol, right? Is that clear?
Yeah.
You look clear?
लेकिन उन्होंने उसको the ester linkage उसको तोड़ के they added another OH.
ये तो हो गई होगा. This will happen. But at the same time, there's going to be alkaline hydrolysis. So what will happen is that the ester link will also hydrolyze. This will turn into a carboxylic acid. This will turn into an alcohol. But since it is alkaline hydrolysis, the carboxylic acid would also eventually react with the alkali to form a salt. Is that clear?
Yes, sir.
Yes.
The plus दूसरा क्या था? Br2, that's because
That's-
it's the phenol.
वो हो गया था.
Br2 gets added. Yeah. और भी question है?
इसी का आगे G part.
B?
G
ये वाला?
इसका आगे.
ये वाला?
No, G. G for gun.
ये last- what's it?
For gun, garbage.
Sir, G. Yeah,
Methyl-
ये वाला.
This is azodine, right? This is your activated benzene. I told you that one of the benzenes is going to be activated. So if you want to do the reverse, before that there's going to be a diazoniamine. The diazoniamine would be formed at the inactive benzene. So you'll have this benzene. SO3 is -1 and Na +1. And this is where the N triple bond N +1 is going to be. You can remember this. When you form an azodine, one of the benzenes is an activated benzene. The other one is an electrophile, which is the diazoniamine. The electrophile gets attracted to the electrons in benzene, right? And that's why you end up with the azo group. So if you want
Step
to do
1
the
में क्या होगा सर? Step 1 में क्या होगा?
Now the thing is, we're starting at this point, so the NO2 has to be turned into a diazoniamine. Now, before that happens, it will form an amine. Where's the chart? Yeah. So the NO2 will first turn into NH2.
H2, yeah.
NH2 will turn into N triple bond N +1. So you need 10 plus concentrated HCl, and then you want NaNO2 plus HCl, and the temperature is going to be less than.
तो reagents हमारे पास 10 और NaOH और HCl.
Just a second. This turns into NH2. So that's 10 plus concentrated HCl. That's reduction.
Okay, sir.
ये जो है ना, that's NaNO2 plus HCl. Plus the temperature has to be less than
110 degrees Celsius.
5 degrees centigrade. So that's this one. Here, और भी question है?
Sir, could you go back to the mole question? I just need to take a screenshot.
ये था। ये ना, एक second.
Yes, sir. This is a little above. No, sir. I need the full question, not the working. Yes, sir. Thank you.
ठीक है। तो और कोई क्वेश्चन है?
Sir, नीचे आप जाएंगे वो question I think D shell calling नीचे है transition के अंदर
कौन सा?
तो
ये
इसके अंदर क्वेश्चन
ऊपर वाला सर
इसके
3
अंदर
question 3
नहीं, क्वेश्चन सी। अच्छा, सॉरी।
ये वाला सर
So we explain the origin of the color of due to
नहीं
it's
सर
the
इसका part C
part C is you've got this. Explain why when aqueous NH3 is added dropwise, a green precipitate. Now this one is exactly the same as वो जो मैंने वहाँ पे show किया था. This one like equation, ठीक है? It's exactly the same.
It's a forward direction, yeah.
1 second. Where we wrote down the equation, ठीक है? Then I told you that when you add a few drops of NH3, it acts as a base initially. The NH3 reacts with water, and it produces OH ions. And those OH ions then go in and they start forming the precipitate. So this first part is that you're adding NH3, right? I mean, he's adding NH3. I think he's adding me. The question is, they form a green precipitate of OH ions in equilibrium and a blue complex of NH3 in equilibrium too. What is happening here? Just a second. So using suggest expression for the following. Explain why when aqueous NH3 is added dropwise, okay, that's a green precipitate forms, the first one. You're going to write that NH3 acts as a base NH3. Right? 1 second. It acts as a base in and you're going to write the equation that the NH3 reacts with water and ends up producing NH4 plus ions and also okay. And then tell them that
हम वो नहीं लिख सकते हैं कि addition of OH ions increases the concentration, shifting the equilibrium to the forward direction, and then forming.
first thing, you're not adding OH ions, you're adding NH3. तो पहले तो आप explain करोगे where do you get the OH ions?
ठीक है सर
Okay.
आप explain करोगे there's an increase in OH ions because he's asking for you have to incorporate the de-Shackler principle. So why are the OH ions increasing? Because the NH3 is producing OH ions. You clear? And now
ठीक है
you're going
सर
to have the equilibrium shift to the right, which is why it clear?
फिर आगे लिख देंगे due to which the equilibrium shifts to right forming the green precipitate of NiOH2
Well, the equilibrium one shift to the right.
The equilibrium is moving to the right, isn't it?
Yes.
Yeah.
Because there's going to be extra OH ions that are getting produced.
Mm.
बस
Now,
सही
the
है
other
सर
thing,
part 2 आता है part 2 वाला उसको skip कर दो
ठीक है.
Or someone was talking about question 6.
6?
Someone was talking about question 6, yeah.
Question 6. Okay.
Sir, question 6 ka part B, they were talking about proteins and secondary and tertiary structure. वो मैंने पूछा था कि is that included?
Not in your course. So this one is obviously a condensation polymer because it's got an ester link. ये B part, this one?
नहीं, इसके नीचे B part. B.
I say even this question is, so why is it, don't forget this. Proteins are polymers of amino acids, complete the table. No, that's no longer in your course.
Yeah.
इसका अगला भी question, significance of hydrogen bonding, DNA वाला.
That's not in your course as well. But let me check this one very quick.
फिर वैसे नालजीन का repeat unit आप बना सकते हैं वो जो वाला question में
मैं करता हूँ. एक सेकंड में चेक कर लो. ये DNA is 0 results. ठीक है, that's 1 second. The nucleic. I'm pretty sure that DNA is no longer in your course. That's pretty sure about that. That's not in your course as well. Any longer? It's 1 second. Where's the paper? I said, कौन सा part? This part?
Repeat year बनाने का कह रहे हैं.
What is nalgene, by the way? I said it's a polycarbonate formed from the diol P, this one, and COCl2, right? So that's easy. Like if you want to draw this, COCl2 is Cl bond O and Cl, right? And this is also Cl bond O and Cl. So what happens is that the carbon, which is very positive, and the O, which has lone pairs, remember phenols only react with acyl chlorides to form ester linkages, right? So the H would be lost and the Cl would be lost. Or either be the lone pairs on oxygen will get attracted to the carbon that's positive, so the Cl and the H will be lost. So what is the repeat unit? I'm going to draw the whole structure first, and then I'm going to figure out what the repeat unit is. So I've got a benzene C6H4. So I've got C6H4 over here as well, and then I have O, C double bond O, and the structure is continuing. Okay? It's going to be C double bond O. And so what is getting repeated? If I start over here, it starts getting repeated again after what point? I think.
Say इसमें भी आपने ओनी ये C6H4 के बाद दो है.
Okay.
Left hand side
Yes,
पे
sir. वो यहाँ पे है.
आपने तो बाहर क्यों निकाला?
I missed an O. अच्छा क्या कह रहे हो कि ये why did I write it outside?
Yes.
नहीं वो outside इसलिए कि this is the point where the structure starts getting repeated again. नहीं 1 second. This is the point where the structure starts getting. What's the where?
O से पहले से नहीं होगा.
Let's start over here. Na serial bond O. The structure starts getting repeated at this point, right? Okay, if I extend this, if I draw the molecule again, there's going to be another of this on this side, right? So it will start getting repeated at this point. Clear?
जी.
You can see the bond O, and then after this it's going to get started because this molecule will be after this as well. It's going to repeat after this. Yeah, if I just make it a simpler version, like I just use this as R, right? So I've got R with two OH groups on both sides, right? And I've got C double bond O and Cl. And I've got a C double bond OCl over here as well. And I've got another R with OH groups, right? So the Cl and the H and the Cl, the H and the Cl, they all get knocked out. So they're going to get knocked out. And what am I left with? The Cls and the H are getting knocked out. So I'm going to remove all the HCls. So this had O. The Cl got knocked out over here. You got an O. The Cls got knocked out, right? So they're gonna link up. This will link up with this. This will link up with this, and they're going to link up. So if I start over here, where is the structure getting repeated? It's going to get repeated after this point. So basically, I mean, replace the R with this thing. So it's basically C double bond O, R, O, and then the same thing gets repeated again. Is that clear?
Yes, sir.
So that's going to be my repeat unit. And remember, repeat unit could start at any point. Like it's not necessary that you want to start at this point. you could start the repeat unit at any point. Let's say I start at this point. When will the structure get repeated again? The ORO comes over here, so it's going to get repeated at this point. Is that clear?
Yes, sir.
With a part, that could be, I mean, you could draw any part as long as it's the repeat unit, as long as that's the thing that's getting repeated.
Sir,
So what,
इसका question 7 है I think bond Haber cycle wala, but they're asking for enthalpy change of formation. This one.
It's a bond Haber cycle. So the lattice energy atomization, so everything is kind of vaporization is given. So enthalpy change of formation, right? They're asking for the enthalpy change of formation. So it's Br2 and that's a liquid, and Zn, which is a solid, and it's going to form Znbr, which is a solid as well. And you're trying to figure out this one. So they've given us the enthalpy change of atomization of Zn. So we're going to do that. Zn becomes a gas. So enthalpy change of atomization is given. That's Br2 is a liquid, right? Remains a liquid. That's 131. What else? They've given us the vaporization of Br2 liquid. So when you vaporize it, it turns into, I mean, the Zn is already, the Br2 turns into, the Br2 is still intact. The bond is still there, but it's now a gas, and that value is 31 plus 31. Now you can use bond energies. You can break the Br-Br bond, because bond energy is only for gaseous molecules. So you can use the bond energy that's given in the data booklet. So 2 Br atoms would be produced, 2 Br gaseous atoms. So you can use the Br-Br bond energy from the data booklet. You clear? I mean, that's the whole confusion in the question, that once you have gaseous bromine, you can use bond energies. Is that clear?
Yeah.
Plus, then you can start turning them into ions. So you need the ionization energies of Zn, which is also given in the data booklet, and the 2 Br minus 1 gaseous ions, right? So you need the electron affinity as well. So it's the first plus second ionization energy of Zn and it's going to be the electron affinity of bromine, which is minus 325, and that's going to be multiplied by 2. And that's gaseous ions forming the ionic lattice. That's lattice energy. That's minus 2678. So this is what you have to figure out. Is that clear?
Yes.
Yes, sir. Information का lattice plus सारी की सारी sum है ना?
किसका?
ये फिर formation का फिर formula ये होता है ना कि lattice energy plus all the values जो आपने sum निकालनी होती है.
हाँ, लेकिन उसमें you have to be very careful about, you have to draw it. You have to be careful about moles. लेकिन in this case, this was slightly different compared to your standard bond Haber cycle.
बस यहाँ पे Br2 की वजह से हम we took bond उसका कहते हैं bond energy.
Vaporization.
हाँ, लेकिन उसमें there was vaporization given. Usually in bond Haber cycle you don't have vaporization.
ठीक है
सर इसके एंड में लास्ट वाला क्वेश्चन, उसके अंदर वो निकालना है वॉल्यूम.
Yeah. अच्छा, fuel cell is an electrochemical cell that can be used to generate electricity. Methanol, do we have any information about the methanol? This reaction is completely different, so I don't think that's a fuel cell. A methanol oxygen fuel cell can be used as an alternative to a hydrogen. So this is given, capture the volume of CO2. Yes. You can calculate the volume of CO2 formed when a current of 2.5 ampere is delivered by the cell for 30 minutes. So Q is equal to IT, so find the charge.
4500. ये वाला पार्ट कर लिया था, इसे आगे नहीं हुआ.
2.5, so that's 500.
Yes.
Then use the Faraday constant to find the moles of electrons. So 1 mole of electrons has how much charge? That's 96,500 coulombs, right?
0.046 moles.
So 4,500 coulombs is going to have कितना आ रहा है?
0.0046.
E?
नहीं. Yes.
That's just here. So you found the moles of electrons. That's 0.046 moles, right? So you can find the moles of carbon dioxide. That's going to be 6 times lesser. It's 6:1. So how many moles do you get for this? What is 0.046 divided by 6?
Sir, हम divide by 6 क्यों कर रहे हैं?
Because according to the equation, if one carbon dioxide is produced, 6 electrons are released.
Oh, अच्छा, हम electrons के हिसाब से.
So the ratio there is 6:1. Like 0.046
It-
moles, the mole of carbon dioxide would be 6 times less. So what is that?
It's 7.67 into 10 to the minus 3.
And then again, so if it's at RTP, you just multiply it by 24 D in cube, and you'll find the or 24,000 C in cube, because they're asking for the answer in C in cube.
सर एक सेकंड 0.46 मोल तो निकल आया, उसको डिवाइड बाय 6 कर दिया. डिवाइड बाय 6 करने के बाद आपका वो कार्बन डाइऑक्साइड के मोल्स आ गए, और फिर आते हैं वो mgv ओवर v वाला फॉर्मूला निकाला है.
कौन सा?
मोलर गैस वॉल्यूम, वो मोलर गैस वॉल्यूम ओवर वॉल्यूम इज इक्वल टू मोल.
That's into 24 D in cube. That's it. So you'll find the volume.
ओके सर, ठीक है सर.
Sir, अगर 2-3 values कम आ रही हो या ज़्यादा आ रही हो, तो is it okay या फिर it has to be inaccurate?
नहीं क्या हो अगर decimals पे ऊपर नीचे हो?
नहीं, the answer in the mark scheme is 187. मेरा 184 आ रहा है.
Exact was, you must be rounding it somewhere.
Okay.
What's the answer in the marking scheme? That's let me try this. It's 1 second. Make sure don't round things on your calculator. Okay? When you're writing it, you should always write it as the appropriate significant figures. But I think 4,500 is a whole number, so that gets divided by what? 96,500. Okay, so that gives you a very long number. It's not just 0.046. It's actually 0.046632, and it just keeps on going. So
Yes.
on your calculator, don't round things. Then you're going to divide that number. You're going to divide this by 6, and that
अब सही
again
है.
into 24,000. So you're going to get, I'm getting exactly 187, rounded to 3 significant figures. Okay?
सही है sir.
Make sure don't round it. I mean, when you're writing things on the paper, you're obviously going to round it off to the appropriate significance. But don't do the rounding on your calculator.
तो यहाँ पे हुआ 3-2 भी तो कर सकते हैं, क्योंकि हमारे पास हर चीज 2 significant figures में गिवन है.
क्या कर सकते हैं?
We can round it off to 2 significant figures as well. कि नहीं?
हाँ, मतलब 1 पे 90 हो जाएगा.
तो फिर वो सही.
What's are they accepting 190?
No, exact 187 लिखा हुआ था.
Just 1 second. Which one is this? This is 2040, right? The last one, this was the last one, right? Yeah, I'm sure they're going to accept 190 as well, because
Yeah, because we have 2 significant figures. I mean, in the question as well.
I'm sure they're going to accept, or maybe in this case they're not even caring about the significant figures.
Yeah, exactly.
चलिए ठीक है, और कोई क्वेश्चन है?
Sir, can we do organic equal division tomorrow with questions?
हाँ, बुक
Organic की reactions की जैसे अभी question नहीं किया था, उसके अंदर मुझे like confusion होती है. Can we do like a whole division of it with questions?
We'll do only organic questions. We'll do different past papers and we'll just do organic questions.
Okay, sir. Hafiz.
चले सर.
Hafiz.